Hello students, under the topic angle of intersection of the two curves, here we have problem 4. Find the angle of intersection of the curves r power n equal to a power n cos n theta and r power n equal to a power n sin n theta. Now in order to find the angle between these two curves, we know that xi is given by phi 1 minus phi 2. So now here phi 1 is the angle between the radius vector and the tangent of the first curve. Similarly, phi 2 is the angle between the radius vector and the tangent of the second curve. So we need to find phi 1 and phi 2 separately and substitute over here in order to find xi, which is the angle of intersection of the two curves. So let us do that now. First we shall take the first curve and mark it as equation 1. So I have taken the first equation and I have marked it as equation 1. Now let us differentiate this equation with respect to theta. So when we differentiate equation 1 with respect to theta, what we get is, now first r to the power n has to be differentiated with respect to theta. So this we will be differentiating by using x power n formula, which is nx to the power n minus 1. So now here, because we have r to the power n, the differentiation of this will be nr to the power n minus 1. And again we have to use the chain rule and differentiate r. So that will be dr by d theta is equal to a to the power n is a constant. So it will be as it is, multiplied with the differentiation of cos n theta, which is minus sin n theta, multiplied with the differentiation of n theta. For theta the differentiation is 1, and so it has to be multiplied with n, because we have n theta over here, n multiplied with 1, which is n. Now further, if you see, this n on the right and this n on the left gets cancelled, and so we obtain dr by d theta to be equal to minus a to the power n sin n theta, the whole divided by this r to the power n minus 1, which is on the left. When it comes to the right, it comes here in the denominator, and so we will be having r to the power n minus 1. So now we have obtained dr by d theta. Next we have to find tan phi. So tan phi 1, this is phi 1 because we are dealing with the first equation. That is equal to r multiplied with d theta by dr. So this will be further equal to r multiplied with d theta by dr is the reciprocal of dr by d theta. So we have to take the reciprocal of this. So the denominator will be written in the numerator over here. So r to the power n minus 1 divided by, in the numerator we have minus a to the power n sin n theta. And so this will be equal to, when you add the powers, because you have r to the power 1 and r to the power n minus 1, and these two are same, so therefore you can add the powers. So r to the power 1 plus n minus 1 will be r to the power n divided by minus a to the power n sin n theta. So that is further equal to, what is r to the power n? From equation 1, if you see, r to the power n is a to the power n cos n theta. So let us make that substitution. So a to the power n cos n theta divided by minus a to the power n sin n theta. So a power n and a power n gets cancelled, and so we obtain tan phi 1 to be equal to, so this minus, what is cos n theta by sin n theta? It is cot n theta. And this can be written as, because we have a minus over here, we can write this as tan pi by 2 plus n theta, because tan 90 plus n theta is equal to minus cot n theta. So by using the trigonometric identity for the angles, we have this. So tan phi 1 is equal to tan pi by 2 plus n theta, because tan 90 plus theta is equal to minus cot theta. Therefore this will be equal to minus cot n theta. So we can now equate the angles because both are tan. So we can take tan inverse on both the sides, and so therefore tan inverse of tan phi 1 will be phi 1, which is equal to tan inverse of tan pi by 2 plus n theta will be pi by 2 plus n theta. So or you just remember that we are equating the angles. Therefore, phi 1 is equal to pi by 2 plus n theta. So this is what we have obtained. In a similar way, let us take the equation 2, that is the other curve, and we shall find phi 2. So now we have taken the second curve and we have marked it as equation 1, and we shall differentiate this with respect to theta now. So on differentiating this with respect to theta, on the left we have r to the power n, which while differentiated it becomes nr to the power n minus 1, and using the chain rule we should differentiate r again, which is dr by d theta, and that is equal to, on the right, a to the power n is a constant, so it comes as it is, and the differentiation of sine n theta is cos n theta multiplied with the differentiation of n theta. The differentiation of theta is 1, so n multiplied with 1, and so we have n. And from this we see that the n on the left and the right gets cancelled, and therefore dr by d theta will be equal to a to the power n cos n theta divided by r to the power n minus 1 to the left. When it comes to the right, it goes to the denominator and it becomes r power n minus 1. So this we have evaluated, that is dr by d theta. Next we have to find tan phi 2. So tan phi 2 will be equal to r multiplied with d theta by dr, which is equal to, what is r? First we shall substitute this, then we will make a change. So r multiplied with, what is d theta by dr? It is the reciprocal of dr by d theta. So we have to take the reciprocal of this. So the denominator will be written in the numerator. So r to the power n minus 1 divided by a power n cos n theta. Now if you see, when you add the powers, it becomes r to the power n divided by, because plus 1 and minus 1 gets cancelled, because we have to add the powers as these two are the same, and divided by a to the power n cos n theta. But what is r to the power n? From equation 2, we observe that r to the power n is a power n cos sin n theta. So let us substitute that. A to the power n sin n theta divided by, we have a power n cos n theta. So a power n and a power n gets cancelled. What is sin by cos? It is tan. So therefore tan phi 2 will be equal to sin n theta by cos n theta is tan n theta, and hence since these two are same, we can equate the angles, that is phi 2 will be equal to n theta. So therefore we have obtained phi 2. Now we have to find xi. We know that xi is equal to phi 1 minus phi 2, or we can also write it as phi 2 minus phi 1, because we will be taking only the absolute value, that is the modulus, positive value. And since here we have, no, here actually phi 1 is greater than phi 2, so we can have phi 1 minus phi 2 itself. If suppose phi 2 is greater than phi 1, then we can take phi 2 minus phi 1. But because here phi 1 is greater than phi 2, we can take phi 1 minus phi 2 itself. So what is phi 1? We have evaluated it to be pi by 2 plus n theta. And what is phi 2? N theta. So minus phi 2, which is n theta. And so when we cancel this, we get xi to be equal to 2. So therefore the value of xi is equal to pi by 2. So this is the angle between the two given curves. Hope you have understood this problem. Thank you.